This is example number 5 out of the 2.6 notes section, which is a polynomial inequality. So the other day we wrote our steps for doing it on the side, but we didn't finish looking at the polynomial. So we have this polynomial, 2x cubed minus 3x squared minus 32x plus 48 is greater than 0. So what we're asking is, when is it positive? Remember, this is a polynomial function, meaning if I graph it, I'm going to have different types of curves, and it's going to fall above or below the x-axis. When I'm looking for the positive, I want to know at what intervals of this function will it be above the x-axis. So to start, I'm going to find the zeros. The zeros represent the only places for possible sign change to happen. If a zero is the x-intercept, from the left to the right could be from negative to positive. It could also be from positive to negative. But I have to keep in mind a zero doesn't always mean a sign change. I could have a zero of different multiplicity other than a 1 that could result in it going up and back down in the same direction or the other way around. So zero does not necessarily always mean a sign change, but it's the only place that a sign change can happen. So if I know where my zeros are, I can test between those zeros, because everything between the zeros is going to act the same in terms of it'll either all be positive or it'll all be negative. I know that because no sign change can happen in between those zeros. So I'm going to start by factoring to find my zeros. In this case, I'm looking at a cubic with 4 terms, and the only way I know how to factor this is to do factor by grouping. So take a GCF out of the first 2, and I'm looking at an x squared. That leaves me with 2x minus 3. And then I look to say, what GCF can I take out of the second 2? Well, I know that I want this to match. I know I want to have a 2x minus 3 at the end. That doesn't mean that I fudge the numbers to make it happen, but I have to think, what's my greatest common factor I can take out? I can take out a negative 16. So now I'm left with x squared minus 16, and then keep in mind we really just factored out a 2x minus 3, which is greater than 0. This x squared minus 16 is what we call a difference of 2 squares, so I can do x minus 4 times x plus 4, all times 2x minus 3. It is greater than 0. Keep in mind I'm looking for my 0, so I'm going to t-bar and solve and pretend that it's equal to 0, because those will tell me where it is 0, and that will help me decide where it's greater than 0. So I have zeros at x equals 4, x equals negative 4, and x equals 3/2. So what I'm going to do is I'm going to set up these intervals, and I'm just going to use a simple number line for now, and then we'll look at a graph later on. But I start by setting up a number line and just putting these in order. I understand that these aren't necessarily to scale, but what I'm looking at is 4 different intervals. So I'm talking about everything up to negative 4, so negative infinity to negative 4. I'm talking about an interval from negative 4 to 3/2, another interval from 3/2 to 4, and then my last interval from 4 to infinity. And remember, everything in each of these intervals will act the same. So everything in this interval will act the same in that it will either all be positive or all be negative, because there won't be any sign change, any change from positive to negative or negative to positive happening here, because the only places where the sign change could happen are these 3 places that we just found by factoring. Those are our zeros. They represent the only places sign change can happen. So what I'm going to do is I'm going to set up a chart where I'm going to test a point from each of these intervals. So I'm going to set up a chart that looks like this. It might not be a bad idea to pause this video and set this chart up on your page right now, because what I'm going to do is now pick a point from each of these intervals and test it. I don't care what the actual number ends up being, I just care whether the answer, whether the output is positive or negative. So I'm going to also try to make as little work for myself as possible. So when I'm looking from negative infinity to negative 4, the nicest number I have to work with is negative 5. When I'm looking from negative 4 to 3/2, the nicest number I have to work with is 0. From 3/2 to 4, the nicest number I have to work with is 2. And then from 4 to infinity, the nicest number I have to work with is 5. I don't want to pick negative 4, 4, or 3/2, because those are my zeros. I'm going to get 0 when I plug those into the function. That's what we just found out. So if I pick those numbers, I'm not going to get a positive or a negative. I'm going to end up with 0. It has to be a number in those intervals. This isn't to say that if you chose 8 for your last interval, you'd be wrong. You're just making more work for yourself. So by picking the next smallest or a nice integer in that interval makes your life a little easier. So what I'm going to do now is plug in my values and see whether or not it ends up being positive or negative. So again, I'm not so much concerned about the actual number as I am about the signs. So this is going to be 2 times negative 125. Just by looking at these numbers, I can see that the negative are going to outweigh the positive, therefore that interval will be negative. 0 will be a nice easy one to test. Because I'm just going to be left with 48, which ends up being positive. Before I make the assumption that the next one is going to be negative, I need to actually show the work. Because keep in mind, a 0 can represent a sign change or can be the place where a sign change is happening. But if it's an even multiplicity at that 0, which we're going to talk about in chapter 3, then I'm not going to see a sign change. It's going to touch and go back down or touch and go back up. It's going to go in the same direction that it came from. So I have to test. I cannot make any assumptions here unless I'm going to write out a more in-depth explanation as to why that 0 would indicate a sign change and note the multiplicities, which we aren't at that point yet. So I'm going to plug in 2. And again, I don't care about the integer. All I care about is whether or not it's going to be positive or negative. And I realize the negative will outweigh the positive here. So it ends up being negative. And then I test my last interval. And realize it will be positive. So I go back to my original question and look to see what they're asking me because I'm not really sure yet. I've done all this work, but I need to go back and just double check what am I even looking for. So when I go back up here, I note where it says is greater than 0. So I also want to make a note of this, in that if I'm talking about greater than or less than, I'm going to use rounded brackets. So on my number line here, I could have used these rounded brackets to show everything on the other side. If you think back to the homework from 2.5, the earlier sections, or 2.6, I'm sorry, you'll notice this where they use this bracket notation. I'm fine with you using open circle, closed circle, but this is essentially the same thing. Keep in mind this would be a closed circle and then this would be an open circle. But on a number line, you can use rounded brackets versus square brackets. The only place you can't ever use a square bracket is infinity and negative infinity. You cannot use a square bracket on infinity because it can't be equal to infinity. It can approach it, but infinity is such an abstract concept that we can't say it's equal to infinity, it approaches it. So I can use square brackets if I'm saying less than or equal to or greater than or equal to, and then I use rounded brackets for less than or greater than or infinity or negative infinity. Okay, so back to what we were looking for, which was where it's greater than 0. That means I'm saying when is it positive? So I go down here, I look for my 2 intervals where it's positive, and I realize this interval is a positive interval, and this interval is also a positive interval. So my answer here, I say -4 to 3/2. That will fall above the x-axis, and from 4 to infinity will also fall above the x-axis. That's my final answer. I'm saying for those 2 intervals, that function will be greater than 0. I'm just going to take a quick look at this function on Desmos. There's the function we were just working with out of our notes. Notice though I put as an equal instead of an inequality. And if you look, here are zeros. A -4, 1.5, and 4. And what do we notice? Everything from negative infinity to -4 is negative, and then everything from -4 to 1.5 is positive. All those points fall above the x-axis. Everything between from 1.5 to 4 acts the same, and everything from 4 to infinity acts the same. So what we're looking for when we said, where is it greater than 0, we're saying what intervals is it above the x-axis? And if I click here, where is it above the x-axis? Everything from 4 to 1.5, and from 4 to infinity falls above the x-axis. An essential piece to understanding this is realizing that the zeros are 1, where the function is equal to 0, and 2, indicate the only possible places for sign change to occur. That's why I can pick one number from the interval from -4 to 1.5, or any interval we're talking about, and it can represent the sign, whether it's positive or negative, for that entire interval. No sign change is occurring between -4 and 1.5 because the only place a sign can change is if it goes through 0. And if I know where my 3 zeros are, then those intervals on either side of my zeros are chunked into these intervals that act the same. So just to recap, we found our zeros by factoring, we t-bar and solve, and then we set up our intervals and test. I find it helpful to write this number line out so I know exactly where my numbers fall in relation to each other and I can clearly see my intervals. And then I set up this chart where I state the interval, I choose a point within the interval, I show my work and am careful with my signs, and then I decide whether the interval is positive or negative. I go back and see what the question is looking for, and then I clearly indicate my answer.